Welcome everyone. In this lecture, we are going to see something more about supercharging. Specifically, we will see the methods of supercharging. As we have already discussed, this is nothing but a method to boost the pressure which of the air which is to be supplied in the combustion chamber in case of a CI engine, or the pressure of air fuel mixture which is to be supplied in case of a SI engine. To boost this pressure or to achieve this objective of increasing the pressure of the air which is to be supplied in CI or air fuel mixture which is to be supplied in SI, different methodologies are used. By methodologies, we mean that the equipment which is to be used to boost the pressure of the incoming charge or air, they are a little bit different. What are they? A compressor, or using a turbine which will drive a compressor, and in turn the turbine is driven by the engine exhaust, or an arrangement in which an engine, turbine and compressor are coupled. That is, the engine will directly drive the turbine and the turbine will drive the compressor, and in which the engine runs the compressor and turbine develops power. Okay, let us see what are the different methods. Types of superchargers. Basically, a reciprocating compressor may be used. Displacement type rotary blowers are also used in some cases. Then centrifugal compressors may also be used. Or when the engine crankshaft drives a supercharger, then it is called as a mechanical supercharger. Or if the compressor is driven by the turbine, which in turn is driven by the exhaust gases which are coming out from the engine, then it will be called as a turbocharger. The basic principle will be same, just that the power to run the compressor is derived from different sources. In simple supercharging, the power may be derived directly from the engine, and when the power is derived from a turbine, which is made to run by the exhaust gases coming out of the engine, then in that case, this method will be called as turbocharging. The main types of superchargers that are basically used are a roots blower, screw type compressors, or centrifugal compressors. Let us see. This is a roots type of compressor which is used for supercharging. It is nothing but a roots type of blower which incorporates the use of lobes. As air is drawn between two rotary lobes, then it gets compressed as the lobes they rotate in opposite direction. That is, the same amount of air is compressed into the smaller and smaller and smaller spaces, thereby increasing its pressure. This is called as a roots supercharger. Its constructional features they include two meshing lobes that are fitted on two parallel shafts. What does it have in working? As the meshing lobes spin, air gets trapped inside the pockets that are formed between the lobes, and it is carried between the fill side and the discharge side. As a result, large quantity of air will move into the intake manifold and it will stack up to create positive pressure. This pressurized air is received at the discharge side and then it is finally supplied to the engine. These superchargers are usually large and they sit on top of the engine. Also, one disadvantage that you can associate with such type of superchargers is that since they are larger in size, they will add more weight to the engine and the vehicle as a whole. Then you have a twin screw type superchargers. In place of lobes over here, you will have two meshing screws in this case. As the threads of these screws, they mesh with each other, thereby drawing air inside them as they keep on rotating successively. Large quantity of air will be compressed into smaller and smaller spaces as these screws keep on rotating. As a result of this, the pressure will increase and finally it is given out from the discharge side from where it might be supplied to the combustion chamber. We'll see what are the constructional features. They consist of two meshing lobes or screws that resemble the set of worm gears. Okay, the two gears, they are going to mesh in such a way that the air pockets that are formed between them, they go on decreasing as the air moves ahead. How does it work? It operates by pulling the air through meshing lobes that will resemble a set of worm gears. They will have a conical taper, which means that the pocket size of the air which is drawn in will go on reducing as the air moves from the fill side to the discharge side. Hence, a screw supercharger will compress the air inside the housing. As the air pockets shrink, air is squeezed into smaller and smaller spaces as we have already discussed. They are more efficient as compared to root supercharger. As they are more efficient, they will cost more because to manufacture a screw and mesh it with a mating screw, more precision operations are required when the manufacturing processes takes place. Also, they are going to make a lot of noise and this needs to be damped out in order to achieve some comfort level and aesthetic. Then again, the compressed air which exits the discharge outlet, it will create a whine or a whistle that must be checked with noise suppression technique. Okay, let us go on a bit further now. Centrifugal compressors. It is nothing but a centrifugal pump. It will draw air through the center. A rotor will rotate, thereby compressing the air and discharging it out from the discharge side. They consist of an impeller, which obviously has several blades rotating at a high RPM in the range of 50,000 RPM. This results in the air being thrown out away from the center of the impeller from where it was drawn in. Why? Because due to the rotation, centrifugal force is created. As the air is drawn in the hub of the impeller, this centrifugal force, it will cause it to move outward in a radially outward direction. As a result, at high speeds the air will leave the impeller but low pressure. This has a diffuser which converts the high speed low pressure air to low speed high pressure air. Hence, pressurized air is achieved. Impeller speeds in this case can reach up to 50,000 to 60,000 RPM. Such type of superchargers are very small in construction, light in weight, and they might be attachable to the front side of the engine. Hence, these serve the best purpose of supercharging. Now, to round it off, the basic difference between a supercharger and a turbocharger. As you can see in the figure above, the compressor is driven by the turbine and turbine is driven by the exhaust gases coming out from the engine. This turbine in turn it drives the compressor which compresses the air and supplies it further to the engine. Okay. In case of a supercharger, the engine it directly drives the compressor which supplies it with compressed air. The exhaust gases are not made use in this case. So we say that for supplying compressed air or air fuel mixture, when exhaust gases coming out of the engine are not used, then that method is called as supercharging. Whereas when exhaust gases coming out of the engine are used to rotate the turbine and the turbine is used to rotate the compressor which is supplying compressed air or air fuel mixture to the engine, then that method is called as turbocharging. Okay, thank you very much.